Alright, welcome back everyone to this channel. In this video, we'll talk about exact differential equations. How to solve an exact differential equation. A differential equation of the form m of x and y dx plus n of x and y dy equal to 0 is said to be exact if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. This is an exact differential equation if this condition holds. M here is a function of two variables, x and y, the same thing for n. So before we solve a differential equation of this form, we first of all check if the equation is exact. That is, we'll ensure that this condition is satisfied. Okay, let us now solve some exact differential equations. Okay, the first equation I have here says solve 1 over x dy minus y over s squared dx equal to 0. This is the differential equation. This equation is in this form. Okay, so let us check if it is exact. Okay, if it is not exact, then there is no need to proceed. But if it's exact, then we'll go ahead to determine the general solution. Now let's identify m and n first of all. Dy is associated with n, dx is associated with m. So in this case now, this will be n, 1 over x. N is what? 1 over x. And what's m? M is minus y all over s squared, which I want to write as minus y x to the power of minus 2. Okay, it's the same. So this is actually x to the power minus 1. So let me take the partial derivative of n with respect to x here. In this case, I'm having just 1 over x here, which is x to the power minus 1. So the partial derivative of n with respect to x, that's partial n partial x, is equal to, let's differentiate this. Here, we just have x, no y. Differentiate this, we have minus 1 times this is minus x minus 2, which is minus 1 over s squared. So this is the partial derivative of n with respect to x. Now, let us take the partial derivative of m with respect to what? Y. So partial m partial y will be this. Here we have minus y s raised to the power minus 2. Since the derivative is with respect to y, that means we will take s raised to the power minus 2 as a constant. That is what it means. If we are taking partial derivative, all right, we'll have a function of several variables. The variable that we are differentiating with respect to is what we are considering. All other variables will become constant. So since this is with respect to y, it means that I will assume x raised to the power minus 2 as a constant. I will take it as a constant. If we are taking x raised to the power minus 2 as a constant, it's like what we are saying we differentiate y equal to 2x. We are not bothered about this 2. We are bothered about the x. Yes. Y equal to 2 in brackets. Differentiate x with respect to x, we obtain 1. Alright, so in this case now, we take minus s to the power of minus 2 out. Then we now differentiate y with respect to y. Differentiate y with respect to y, we have 1. And so what would this be? Minus 1 all over x to the power of 2. So we can see that partial n partial x is equal to partial n partial y. Look at it, they are the same. This shows that this differential equation is exact. So on this note, we are going to proceed to obtain the general solution. This is m and this is n. So the first thing we are going to do is to integrate m integrate this m with respect to x. Okay, so we are taking the integral of this function with respect to x now. The integral of minus y x to the power of minus 2 dx plus the next thing is integrate with respect to y only those terms of n which do not contain x. I repeat, integrate with respect to y only those terms of n which do not contain x. If I look at n now, n is equal to 1 over x. The function here contains x alone. There is no y term here. So I cannot actually integrate with respect to y the terms that do not contain x because the term here contains x. All right, I hope you get the point. So there is nothing here. So result of this plus the result of this is equal to the constant. Now this is it. I want to say it again. The first thing, integrate n with respect to x. All right, this is it, the integral of minus y x to the power of minus 2 dx. The second thing is plus, we now integrate with respect to y only the terms of n which do not contain x. We wrote 0 here because n is equal to 1 over x. There is no y variable here. So we can't actually integrate with respect to y the terms that do not contain x because the term that we have here contain x. Maybe in the next example we're going to see something that contains x and y. Okay, but this is for this. So since we're integrating this with respect to x, it means that y will be a constant. So I can bring y out and take the integral of x squared x to the power of minus 2 dx equal to c. So this is minus y. The integral of x to the power of minus 2 dx is x to the power of minus 2 plus 1 all over what? Minus 2 plus 1 equal to c. So we have minus 2 plus 1 is minus 1. Minus 1 will cancel this minus here. So we have y times x to the power of what? Minus 2 plus 1, which is still minus 1, equal to c. So y x to the power of minus 1 is y all over x to the power of 1, which is equal to c. So if we cross multiply, y is equal to c times x or x times c. This is the general solution to this exact differential equation. All right, let's see another example. This looks like an exact differential equation because we have the form n of x and y dx plus n of x and y dy equal to 0. So this is it. Let us identify m and n. M is associated with the x. So this is m. M is equal to 4y to the 5th minus 6 times e to the power of x. Okay, we can actually expand this to obtain 4y to the 5th e to the power of x. That's this times this, then this times this, minus 6e to the power of x. What will be n? N is associated with the y. So this is n. Let's expand the bracket. 20y to the 4th times 2y. That's actually 40y to the power of 5. Yes. Then this times this. That will be 20y to the 4th e to the power of x. Let us check whether the differential equation is exact. Going by that condition for exactness that says the partial derivative of m with respect to y is equal to the partial derivative of n with respect to what? X. So let us determine the partial derivative of m here with respect to y. That means we will differentiate this function with respect to y, keeping the function of x as constant. So in this case now, for this first one, 4y to the power of 5 e to the power of x. We will take 4e to the power of x as a constant. Then we differentiate y raised to the power of 5 with respect to y. And that will be what? 5y to the power of 4. Okay? Then this is a constant, minus 6 to the power of x. So if we differentiate a constant, we'll get 0. So that one is out. We now have 20e to the power of x, y to the power of 4. This is partial m, partial y. What is partial n, partial x? Partial n, partial x is, let's differentiate this now with respect to x. So the variables y will be taken as constant. This is 40y to the power of 5. Because we are differentiating with respect to x, the derivative of this becomes 0 because it is a constant. So we have 0, this is out. Then let's differentiate this now with respect to what? X. We'll take 20y to the power of 4 as a constant. 20y raised to the power of 4 as a constant. If we differentiate e to the power of x with respect to x, it is still e raised to the power of x. So you can see that this is the same thing as this. 20e to the x, y to the 4th. So partial m, partial y is equal to partial n, partial x here. They are the same. So it means that the differential equation is exact. So let's now go ahead to determine the general solution. The first step is integrate m with respect to x. This is the integral of m is this. This is m. 4y to the 5th e to the x minus 6 e to the x dx. Okay. Then plus, we will now integrate with respect to y only those terms of n which do not contain x. This is 40y to the power of 5, and this is 20y to the power of 4 times e to the power of x. This term contains x because of this e to the power of x, but this one does not contain x at all. So we are going to integrate only this one. That is what we are saying. Only the terms of n which do not contain x. Okay? So this term does not contain x at all. So we'll take the integral. This is plus the integral of what? 40y to the power of 5. 40y to the power of 5 dy. It is integrate with respect to y only those terms of n which do not contain x. And that's what we are doing. The result of this plus the result of this is equal to the arbitrary constant. This can be written as the integral of 4y to the 5th e to the power of x dx minus the integral of 6e to the power of x dx plus, okay, I can write this as 40 times the integral of y to the power of y to the power of 5 dy equal to c. Since this integral is with respect to x, that means 4y to the power of 5 is a constant. So 4y to the power of 5 is a constant. The integral of e to the power of x ds is still e to the power of x. Yes. Then we have minus. This is with respect to x, the integral, and we just have a function of x here. So this is 6e to the power of x. Okay? Integrate e to the power of x, it is still e to the power of x. Then plus, here we have 40 into the integral of y to the power of 5 dy is y to the power of 6 all over 6. Everything is equal to what? The constant c. So let's simplify. We have 4y to the 5th e to the power of x minus 6 e to the power of x. Okay, we can break this down. 2 here is 20, 2 here is what? 3. So this is plus 20y to the 6th all over 3 equal to c. This is the general solution to this exact differential equation. So this is how to solve exact differential equations. Alright, I hope you enjoyed the video. Keep supporting by subscribing to this channel Like the video and share it to your friends and to your classmates. I'll see you in the next one.